Then your job is maybe a different job. As far as I almost always one person will manage this one of the kids.
Okay. Yeah. Good morning, everyone. Let's start. We have a busy schedule today. Okay. Welcome to the Lisp working group. I'm Luigi, here by Joel. We are the co-chairs of this working group. In the first row, we have Padma, our secretary, will take notes today. Wasim, thank you, Padma. Wasim couldn't make it this time. He had to leave yesterday for other things. So, as usual, they're not well, stating that whatever you say today here is a contribution to the IETF. The usual pointers, blue sheets are running. We have the links to the charter, audio stream, Jabber room, agenda slides, etc. Quick status updates. So we had the Lisp security draft that was in IETF last call, came back for a simple reason. We are chartered to do standard track work. SEC was still experimental, so rightfully comes back. We will is already submitted as a standard track, and we'll work on it, make sure it's coherent with the BIS documents, and then move it forward. Signal free. Past last call, I'm doing the write-up for the to hand it to Deborah or D. Okay. So the drawback of the fact that the SEC document came back is the fact that the introduction document will wait a little bit longer because there is a missing reference to the security document, right? But I mean, it's been there for 900 days. So a couple of months more is not a big issue, I would say. Okay. And then there are the 2 BIS documents we have to move forward. I plan at least to finish the 30 BIS by Christmas, guys. So I will push on the mailing list to make progress. Okay. We'll come to that later. So the agenda is an update on the BIS documents, security, the Yang model. These are the working groups items. Okay, and we have a bunch of non-working group items. So the reliable transport, RAM-based Lisp for avionics, Deluxe GPE, the pub subscribe document, traffic engineering, a demo with Android and iOS implementation. Exciting. And then control plane, authentication and authorization, and mobile. Okay. Sorry. Deborah.
Yes, Deborah. On the security, it wasn't so much that it was experimental and we're doing standard. It wasn't so much that it was experimental versus standards track. I just felt that with the BIS work going on, that we will be doing standards track. I think there's a lot of emphasis on security, as you all know now here at IETF, and I felt that to ensure that we get our BIS documents through, it's going to be really important to have the security document, and it's not going to be favored so much that that's just experimental. So let's just swallow the bullet and make that standards track, that we have a good reference for the BIS work.
Okay, thanks, Eber. So unless there are comments and you want to change anything on the agenda, Albert, with the first item.
Okay, so I'm going to give an update on the BIS documents, so explain which are the changes since the last ones, both for the data plane and control plane. So next slide, please. So for the data plane document, since last IETF Chicago, we had 4 versions of the document. Mainly, they are the result of some discussions on the mailing list. So some discussions that then propose some changes on the documents, which I will say that they are mostly editorial. So next slide, please. So there are many aspects that have been clarified because at the time of the writing of RFC 6830, some aspects were still under debate. For instance, what to do with UDP checksums for IPv6. So this has been clarified. We have clarified the definition of the RTRs, which is basically an editorial work. We have removed a statement that said that EIDs must not be used for airlock space, since this is actually relative to the deployment. That's something that we learned from the original document. Again, and for the same reason, state that airlocks are routable in the airlock space and not globally routable, as it was stated before. And the reason is the same, because that's relative to the deployment. There are some deployments which this might not be strictly true. Another similar statement state that the map cache is generally short-lived as opposed to short-lived, which again, it's a fact. Then state that AFI pertains to the data plane, because before we were saying that it was either an IPv4 and IPv6 addresses, and deployments have shown that this is not always true. So next slide. Again, because of other protocols, state that TTRs may not will send always the map replies. We are changing a mandate to recommend in the maximum number of list headers that one can prepend, again, because of some deployments are actually doing that. We have added a reference to VPN in the instance ID section. We have clarified the use of the EBIT, also the use of some private addresses, and I went to use instant ID and remove the reference to 1918. So next slide. Regarding the control plane, we only had one iteration. So next slide, which is basically adding the IBIT, which is for publish subscribe. So that's the only change that we had here. And I believe that that's the last one, right? Yeah. So next. Yeah. So the last one. So.
Any comment or question?
This is Dino. Can you hear? Test. Yeah. Okay. Swallow it. Okay. So we had one comment from you, Albert, about we made a reference in 6830 to some research that's going on. That research has finished a long time ago, many years ago. So the recommendation by Albert was to remove that so we could put a new update out and send it to the list and see what they think. On 6833 BIS, Alberto just came out with a set of clarifying comments. They looked non-controversial from first glance, but we'll have a look at them next week. But I think we've had a lot of opportunity for commentary over a long period of time. I think we're ready for last call and would like to request that. I don't know what you guys think.
I have a comment on that. I was reviewing the 6830 BIS thoroughly. So
you have comments as well.
That there are some sentences like, we will look at this in the future. that which have to be
The
dropped.
future's maybe the past,
There
yeah.
are some sentences, relic sentences about scalability issues. That
Okay.
and there is still some text that doesn't really fit in the data plane. Okay, but we don't have time to go into details today. But I want to push this on the mailing list
Okay.
in the coming weeks, because I would like to be done at least with 6830 Bs by Christmas.
Okay,
So
good,
expect mails.
awesome,
Okay, and keep an eye on the mailing list.
okay.
Okay.
And the goal for 6833 is a little bit later then? Maybe,
Right after, not a little bit.
Ah, okay.
Right after.
so the next
forward.
IETF, this should be all, RFC editor stuff. New Year's Eve, okay. What time zone? No,
Yeah, you have time until midnight, right? So,
okay.
okay.
Thank you.
So this is Lissec. I'm Fabio Maino, Dioto, Sarvina, Albert, and Damien. Some of them are here. Next slide. So yeah, this is what Deborah was introducing at the beginning of the meeting. This is the reason why Lissec was moved back from last call. I think she explained very nicely the reason. So this is just a record of what she was saying there. Next slide. We have done a few changes due to comments that have been made. Those were my... Oh, sorry. Oh, I can watch here. Cool. Yeah, easy. So minor changes. One was about the recommendation to refresh the Lissec share keys to address key aging. And now there is a small section that is basically recommending that. Key aging and key compromise, of course. There were some questions on how the protocol is resilient to replay attacks, and basically the nonce that is generated and stored at the ITR is providing that protection, both for reply attacks that are mounted on the map request portion of the protocol and the map reply portion of the protocol. And then a few considerations on the role that Lissec plays to mitigate denial of service and distribute denial of service. Mainly preventing overclaiming attack is the big portion of the work that Lissec does. Next slide. And this is actually the text changes that are that have been done since the last version. Next slide. Yeah, I don't know exactly what is the process, so I don't know, should we move to the last call, wait, whatever needs to be done there. So,
I would say would be wiser to keep it a little bit more in the working group, just to make sure it's coherent with the BIS documents, and then move it along. I mean, anyway, if we move it now, we'll be stuck.
Yeah, exactly. It doesn't make much of a difference.
The BIS documents, and with the risk that is, for whatever reason, we have to change the SEC document to be coherent with the BIS documents, we have to take it back.
We need to do last
So,
call again, yeah.
Would be wiser, I think, to keep it here, and then right after moving along, just quick make sure that there is no issues. I don't think, but
Yeah, you know, whatever is the easiest
I think-
process, I think is the right thing to do. Yeah, exactly.
I think we need to couple it, but there's a message there for the working group. Folks, make time to look at these three documents now, because they were going to be last calling all three of them, and you don't want to be trying to fully read from scratch if you haven't looked at them, all three documents. So read them. They're close enough now that you're going to get almost everything you need from your review. You'll want to look again when we last call them, but please look at them now, get comments to the list if you see something, so that we can make sure these are in good shape and we can get them through last call and hand them to Deborah for the IESG.
And we don't have to do that during our Christmas vacations. Yay.
Thank you.
Hi, I'm Rashad Rahman. I'm going to be presenting the, can you guys hear me? Yeah? Okay. So Yang model update, next slide, please. So the current Yang model was updated right before Prague meeting. I was supposed to present it, had some flight issues. It has not been updated since. We've got no comments on the mailing list. I'm hoping that we'll get some comments on the mailing list after this IETF. Some of you may be aware of the NMDA guidelines, which has been going on all over the place in IETF. So that's part of the main change we made in the latest rev in July, is to basically not have separate containers for configuration data and for operational data. What the NMDA does is it gives you a new data store, which is for the operational data store. And there's metadata, which annotates, which gives you what's the source of the data, whether it's intended, meaning from configuration, or whether it's learned dynamically from your protocol, for example. Next slide, please. Yeah, so we removed the duplicate containers across the models. For example, now we have a single map cache on ITR and PITR for both static and dynamic. Same stuff for the map server. We had lots of references to state, config, CFG, etc., and descriptions. That's been removed. Next slide. One change we did, we added the XTR ID type. So this is not related to the NMDA guidelines, but previously we had the XTR ID and the site ID replicated in the ITR model, the ETR model. So that implied that depending on your role, you could have a different ID. So we've moved that back in the Lisp router instance, which is in the main model, the IETF Lisp model. But on the MS, on the map server and the map resolver, you can handle multiple sites. Next slide, please. A map server, previously, the authentication key was per mapping, I believe. We're doing that per site ID now. We've added the site XTR IDs to the mapping records. And we've also reordered the tree, the data tree a little bit, that the VNI is the parent of the mappings now, as opposed to being an attribute of a mapping. So it makes it easier if you want to look at all the mappings for a certain VNI.
This is Dino, real quick question. Why did you move the authentication key to site ID rather than the prefix?
Okay, glad you brought, so discussion we had was, as far as we know, the implementations, the most common implementation is to have it per site ID. And the discussion is if it's uncommon to have it per prefix, that could be done as an augment, but not in the base. The implementations I'm aware of have it per site ID.
So if somebody wanted different authentication for different EID prefixes for the same site, they would have to configure them as separate sites and still get a...
Well, with that model, yes. But if you want to support what you just asked for, we would need to augment the model. It could be a vendor-specific augmentation, or maybe it's an augment as part of the IETF.
So if you want EID prefix authentication, just configure it as separate sites. You're not taking the functionality away. They just have to do it a little differently. And if you say there's popular implementations that do it that way, then it's probably not that much of a problem, right?
That's our opinion, yes. Next slide, please. We've merged, we had separate models for PITR and PTR, and for Peter, sorry. So we've merged those with the ITR and ETR models. We're using a one statement, and the present statement for ITR, it enables both ITR and PITR operation. We've done the same for ETR. Next. That gives you high-level view of the hierarchy. You can take a look at the data tree to give you a better idea. But that's basically a reflection of what we've been discussing in the previous slides. Next, please. Minor changes, we've added a creation timestamp to the mappings. Also now the PETR configuration is per ITR, it was per mapping earlier. And we've updated all the versions except the Lisp address types, which hasn't changed. Next, please. So We would like some comments from the work group, but I guess the comments we're looking for is, I mean, on the configuration too, but we feel that maybe there's more operational data which might be needed, counters, stuff like that. And a private comment we got was to take a look at the ListMib. I'm not very familiar with the ListMib, and compare the data which is in the ListMib and which is not in the in this Yang model. So that's what's next on our plate. And I believe that's it. Yeah, so this is, yeah, done.
I have a question on this slide. I mean,
Yep.
if you say that the ETR is per ITR and not per mapping, which means that absolutely you have no choice to send use different PETRs for different prefixes. You have just one PETR. That's the point.
One or multiple. Yes.
Yeah, but
Yeah.
you
cannot do it
you
per
have-
prefix. You cannot do it per prefix right now with the way the model is.
Okay.
So if, you know, people feel that that functionality is either needed or fairly common in implementations, we can definitely consider adding that back,
Okay.
either via an augment of that base OK model or by adding it in the base model.
Okay, Stepper. I saw this was experimental. Most of the Yang work we're doing, it's standards track and IETF, and I was just wondering, could this be standards track? Because especially you say you have implementations.
So I think it was experimental. I mean, I was not one of the initial authors. I think it was experimental because that's what the other Lisp
The
document-
work was started before we started putting this, the base work on standard track. So I think it would make very good sense to move this to be proposed standard as well, and we'll advance it behind, but not very far behind, we hope, the other documents. So yes, moving it to standard track would make very good sense.
Okay, so the community now has 4 documents to read and not 3.
Yeah, because the strong interest rate from the ISG, not only in security, but in management. And so if we can show we also have a document in the pipeline for the Yang, that would be great. And the other thing I would strongly encourage is if you could get some of this to the hackathon, that we could show the implementations. And if you have any open source, right, that's because that's why I'm also thinking to make it standards track, because the open source community, if anybody's interested and they see this as experimental, that they're going to just shy away from it, and it would be much stronger if we can say this is standards track.
Yeah, just wanted to mention that yeah, there's been, I know you did quite a thorough review with your coworker, and that was about a few implementations, right, on that. There is also an implementation on OOR, an open source implementation, and that has also, contributed to a review and, making sure that that was aligned. So I think we have quite a few implementation available, and yeah, I totally second the idea of bringing this into standard track, and if we can show it up what we have in open source, that would be really cool.
Okay.
Okay, so I'm going to be presenting the Lisp Reliable Transport. I'm not one of the authors. I'm presenting on behalf of the authors who are listed here. Next slide, please. So some background on this. This was presented at IETF 91. It replaced, the previous name of that draft is written there on the first bullet. The main change, I'm just going to give a quick recap what was presented in 91. I'm sure some of you might have forgotten. And the main change in the document since IETF 91 is adding of the scope field in the refresh procedure. Go over that soon. Next slide. So currently with UDP registration, this is your typical soft state problem, which has happened in RSVP and other protocols where you need to continuously refresh your state. The constant communication puts a load on your system. And we feel that because of use cases for high scale that we need something which addresses the scaling issues with soft state refresh. Next slide, please. So what's the alternative? The alternative is you use TCP/US CDP to do a reliable session between your ETR and your map server. You use that session to communicate, to do all your registrations. It's being proposed as an optional alternative, so it's optional to the current UDP-based registration. You have to support UDP. You can't just use TCP for your registrations. There's a single session, for example, between your ETR and your map server, and you can, use that same session for any other future applications. And the message exchange is TLV based for extensibility. Next slide. That's the message format. Nothing much to say. It's very straightforward. Next. Okay, so we've reused the registration message from UDP just for simplicity. So that's your registration message is one OK message type. You can also have a registration acknowledgement or reject from the map server to the ETR. And the third bullet, that's the scope thing we're talking about in the earlier slide, where you can ask, the map server can ask for selective refresh. You can ask for global scope, which is everything. It can ask for a certain address family, or it can even ask for certain prefixes. The mapping notifications, as they are in UDP, not really needed for registration acknowledgement. So we have a new message in TCP, which shows the merged map server view of the mapping when merging is in use. Next, please. Oh, map server operation. So after the registration is obtained via TCP, there's no timeout of that registration unless the TCP session goes down. Then we fall back to timer-based expiration. The registrations can be rejected for one of the reasons listed here. So the refresh request can be issued to the ETR to obtain initial state. So for example, after a TCP session flap. And already spoken about the notification message. Next. So basically the ETR does regular UDP registration until the reliable transport session is established. And there's no refresh in the reliable state unless the map server asks for it. Next, please. So basically, conclusion, we're using TCP or any other reliable transport between the ETR and the map server. It eliminates the need for periodic refresh, uses TLV, could reuse the session. And there are existing implementations of this, and they've been very effective. They are deployed. They've been very effective in large-scale Lisp deployments. And next one is the last one, I believe. So we would looking for comments and would like to ask for adoption by the Lisp working group.
This is Dino. This might be a radical comment, but we are probably in a technology transition now. Maybe the question should be asked, if we can keep the messaging same in Lisp and run it over quick, we'll have a UDP interface, we can use the same port number, and we get security for free. You haven't said if you use TLS here, and I'm seeing requirements for having the interaction between the mapping system be encrypted. So I'm just wondering if we should maybe spend some time or get some folks together and see how Lisp can work over quick to make it reliable. So I don't know, do you think that's radical?
Well, it's radical, but I mean, my first reaction, I can't say just because we've done this that it should not be considered. You have a good point that that's where we are now as opposed to 3-4 years ago. So.
Okay, no more questions or comments? How many people read this draft? See.
Me too.
Doesn't make really sense to have a consensus with only 4 people reading the document. So, but please, all read the documents. We will come back to this question. Okay? I mean, if we adopt the document, I don't see why it should stay experimental.
Okay, that's the last one, ground-based Lisp. Next slide, please. So this is a new draft which was submitted in September. There's various authors in a way you can take it. So the background of this, I mean, actually the background for you who were there in Prague, I believe Fred, who's sitting here, gave a presentation for a BGP solution for exactly this. So the ICAO is proposing a new network which would be IPv6 based, and they call it ATN IPS. And that new network would be, you know, for the air traffic systems, the air traffic controllers, the airline operation controllers, and all that. We presented the draft at the ICAO meeting in September. And basically, there's no protocol, there's no new protocol extensions as part of this. It's informational, and it builds on mechanisms which exist in Lisp already to show how we can do this. Next, please. So you're going to hear a bunch of acronyms. On the left, okay, so that's not showing us. Okay, there's supposed to be two airplanes on the left there. You basically see two radio regions. Those could be SATCOM, VHF, and basically the plane is moving around and gets connected to the core or inter-working region here based on what radio regions it connects to. You see the three circles in blue. Those are supposed to be XTRs. One is an air ground. The two on the left are air ground routers. So between the air regions and the ground. And the one on the right, the GGR, is a ground router, which is also an XTR. And we have a Lisp MSMR at the top there. Next slide, please. I'm sorry? Okay. Thank you. Okay, that's not showing. Are you doing it with the PowerPoint or with the PDF? Okay, so is that my old slides? Those are my old slides, and because I sent a new PDF because the. Okay, so yeah, I didn't know if you were going to present the PowerPoint or no. It's okay. So you see the nice little planes on the left there, and so it basically shows. So each airplane gets a prefix. We're showing two airplanes here. We know prefix X and prefix Y. There's routers. So why we call it ground-based Lisp is because there's no Lisp mobility is not running on the airplanes. The Lisp network is basically the interworking region there on the right, where the air ground routers and the ground routers are acting as XTRs. Next. Yeah, so this shows without animation how the registration would happen and how the ground-to-air traffic would flow. So step one, you see that the aircraft is attaching to the access router on the top, and that information gets transported somehow, for example, via an IGP to the air ground router, which does the registration on behalf of the aircraft, for the aircraft EID with the MSMR. And step two is exactly the same thing, except that it's on the radio region 2. The important thing is there's preference. So different radio regions, I'm not a radio expert, but different radio regions have different characteristics. So the aircraft might decide that they prefer a certain radio link to another, and that gets signaled over to the access router, and that gets reflected into the Lisp priority when the registration happens. Step 3 here, we see an ATSN system trying to send traffic to the airplane. The ground router does a map request to the MSMR. The MSMR knows that the air ground router of region 2 has better priority. So the map request is forwarded to that air ground router. The air ground router responds with a map reply, and then the ground router sends the traffic over the tunnel. Next slide, please. So default forwarding path. Typically in Lisp implementations, when you're sending a map request and you don't have a map cache entry, the many implementations will drop the packets. In terms of the requirement, we're told that that was something which was undesirable. So what we're proposing is to have some form of configuration on the ground router for its default forwarding path, and the default forwarding path would go to an RTR. So the traffic would be encapsulated to the RTR, and the RTR would, by some means or the other, it could be collocated with the MSMR, it could be using PubSub, it would have all the mappings in the network. So the XTRs are still doing the pull, but the RTR is using PubSub. So we see after the map request is sent, traffic is sent over the default forwarding path to the RTR. So that's the suboptimal path. Step 3, we get the map reply back, which says what ETR to use. And then the ground router, step 4, sends it over the optimal path. Okay, mobility. So this, call it optimized because it works around the issues we have with map cache, TTL, and stuff like that. So here in the slide 1, you can see that the traffic from the end system to the aircraft is going over radio region 2. That's a connection the airplane has right now using the procedures we described previously. Next slide, please. So now the aircraft connects to radio region 1 on the other access router, and the aircraft prefers to go over radio region 1. So that again, the air ground router gets that information, for example, via the IGP. Registration happens, and with a better priority. Now, typically, the map cache would have to expire on the ground router. What we're proposing here is we can use PubSub, and the ground router would be notified, for that aircraft prefix, that there's now a better path. Next slide. And the switchover happens before the map cache expires. HA, typical stuff, redundant map servers, ground routers, air ground routers, again, all that. You can have multipathing in the underlay, and also the aircraft is not attached to an anchor point. So it's if the anchor point fails, the fate of the aircraft, traffic to the aircraft is not impacted. So you don't have the triangular where it always has to go through the same XTR. Next slide. Security. So yeah, you can protect the control plane using LispSec. You can encrypt the traffic if needed using 8061. And your DOS mitigation is, the usual control plane limiting. You could also do stuff like ACLs where you say because the IP addresses are fixed. The prefix of the aircraft is fixed, that this belongs to a domestic aircraft. I'm not expecting that to register over a radio region, which is international flights and stuff like that. You could do that. Next. Looking for comments. Now or later.
Comments, questions?
Peter Ashford-Smith, Huawei. Just a quick question. Is there any requirement for a ground-based wired connection when the aircraft's at an airport?
I don't know. Fred?
Would seem very reasonable.
So the question again was from the ground-based to the aircraft, wired link?
When the aircraft arrives at the airport, they plug a cable in.
Oh, they call that gate link, actually. That's just another example of a link that an airplane would use. En route, it would be using VHF or SATCOM or another link called LDAX. So there's no ground link required there. You're over the air there from the aircraft when it's in transit.
But on the ground,
Yeah,
and the XTR at the airport,
it's just another link. The ground-based gate link is just another link. But I had another comment. This is Fred Templin from Boeing. ICAO is actually meeting this week up in Bangkok, and I was there on Monday. And ground-based Lisp is one of 3 proposals that they're looking at for what they call the mobility solution. A second proposal is the simple BGP method that I talked about last time that Rashad mentioned earlier. And now they've also brought proxy mobile IPv6 into the picture too. So 3 solution proposals are being looked at, and they're going to be down selected over the course of the coming months.
This is Dino. I just want to make a comment about when you're parked at the gate and you have a wired connected. That could just be another mobility event, right? And I think that's maybe what you were getting to. Use the same machinery, and it doesn't matter if it's wireless or wireline. There'll be a ground-based XTR there that would have a new locator at the airport.
I had as well a question. Is there any critical traffic that goes over these links? Because you can imagine to actually duplicate the traffic onto RLOCs, meaning that so that you are sure that, no, you increase the probability that arrives at the destination.
Yeah. I think we got comment like that. Was it you, Dino, who had suggested that, I believe, about duplicating the traffic to
For
ETRs?
reliability, for critical traffic. I mean,
Yeah. That's a possibility, yes.
Yeah, just a note. It's a very articulated use case. It's interesting to note that this is pretty much basic Lisp, right? There isn't anything new. Also, I think it's interesting to note that one of the few optimization that can be done is using PubSub. That is the direction where we are trying to move the protocol. So I think it's a nice use case articulating the value that Lisp brings, and also is probably confirming that some of the direction that the working group has been going on to evolve Lisp are okay.
This is Dino. Yeah, I agree, Fabio. I'm kind of excited because the EID mobility draft is showing that this one mechanism could be used for all these use cases. We found VM mobility uses EID mobility, this airplane or aeronautical application, and we'll show that the 5G proposal we're making is using the exact same thing. And what they all have in common is that the EID and the RLOC aren't co-located in the same device. They're actually separate. So we're finding that this, the generality and the level of indirection is becoming quite useful for many use cases with no new machinery being added.
More questions, comments? Okay. Thank you very much. In the being square.
Hello, I'm Mickey Spiegel from Barefoot Networks, and I'll be presenting the IOAM work on VXLAN GPE. So you can see there's a lot of authors. Let's move to the next slide, please. So what is IOAM? Basically, it's a mechanism to gather a bunch of telemetry and OEM information along the path, and we're doing that in the data packets that you normally send. So you don't need to send additional probe traffic or so on. You're just appending information to data packets on one end of your network, removing it from the other end of your network, and then reporting it. And you can see kind of in real time all this stuff about what's happening in your network. It can be node IDs, it can be interface IDs, it can be transit delays, it can be timestamps, so queue depths, all kinds of stuff about the way your network is actually behaving and what's going on in there. So the general concept of IOAM and the details in terms of data fields and all that is being taken up in the IPPM working group. So we have a working group draft there with all the details and all the fields. And now the question is, okay, we have all this info. How do we encapsulate that in various transport mechanisms or transport encapsulations so that we can apply this in all kinds of scenarios? And Lisp is potentially one of those things where we could embed all this information and see the way the network is behaving. If you have any sort of generic multi-protocol encapsulation where we can put this thing. So there has been some discussion of using VXLAN GPE as a data plane transport for Lisp. And to that extent, we could use IOAM over VXLAN GPE as a way to capture all of that. Next slide. So basically the way it would look is you would have all your outer headers, then you have your VXLAN GPE, and after the VXLAN GPE, you would put all this IOAM information. So there's some an IOAM trace header that tells you what kind of information you're capturing, and then a bunch of data fields showing what's going as what you've collected as you go across the network. So at the moment, the current proposal is you have a next protocol field. So the next protocol field in VXLAN GPE would then refer to your IOAM stuff. If we go to the next slide, one of the questions in the design is whether that should be one code point, which is what you have on the right, but that kind of leads to nested TLVs because then your one thing is a length and then you have multiple things with lengths inside it. Or if we have a few different code points, and the reason for the few different code points is we have a few different things that we're doing. We have a hop by hop collection of information. We have an edge to edge. So on one edge you insert information and then you remove that at the other edge of your network when you're reporting all the information. We have a proof of transit. So if you're doing an NFV type of thing and you're using Lisp to go between different middle boxes, then you can actually prove that you're going through the middle boxes you wanted, which is a major security issue if the point of the middle boxes is to deliver your security functionality. So the figure on the left is showing that if we give a different next protocol code point for each one of those, for the hop by hop, for the edge to edge, for the proof of transit, then it's easier for the hardware if you're doing a hardware solution. It does mean that you may have to go through, one or more. It could be more than one next protocols that you have to jump through, each of them having a length. So it's not hard to jump through. And so we were requesting some feedback on the left versus the right. The expectation is if we go with the left, you may get more implementations that can support this in hardware. But both options are things that we're willing to discuss and get feedback on. So, so at the moment, as I mentioned, the data fields is adopted by IPPM. Now we're looking at various encapsulations, and this is one of the places that we're talking to. We also presented NSH at SFC and Geneve at NVO3. So we're mainly here to request feedback. And
so you're requesting feedback. Is your eventual assumption that if you got assigned a next protocol from various other places, that might be a next protocol carried in Lisp? Is that what you're suggesting here?
Yeah. So
because otherwise,
so there's a couple of hurdles that have to go through here. So one is Lisp going to use VXLAN GPE or some other generic encoding?
No, Lisp already has its encapsulation.
There's been discussion of various encapsulations.
No,
for
there's
data
been
plane.
discussion of other groups defining encapsulations and using the Lisp control plane.
Okay.
The Lisp working group is not going to define alternative encapsulations to
Joel,
Lisp.
can I make a
There's
comment?
distinction.
Right. So the comment is that now that we have separated the control plane and the data plane of the Lisp working group, right? The question arises of there are some capabilities in RFC 6833Bs that can be used independently from the transport that we're using, right? For example, if you use Lisp encapsulation, doing a layer 2 overlay is not, trivial. I would say. So that opens up the opportunity for Lisp control plane, RFC 6833, right, to be used in conjunction with other encapsulation. For example, you could use it with VXLAN.
Yeah, but that work would be done in other groups. We're not going to get into defining how Lisp works with other groups. I mean, we will happily consult to some other group. If the NVO3 guys said they would like to be able to use Lisp as a control, we would work with NVO3.
But
I'm not going to, I specifically do not want to get into any risk of this working group trying to standardize encapsulations that are not standardized somewhere else. That is not our remit. And that's why I'm trying to be careful here.
Joel, we are specifying a protocol, right, that can be used and do a certain things, right, like layer 2 overlays, and we are basically not providing a question on how that can be done. One thing that I would suggest from my point of view is, can we look at RFC 6833, right, and say, okay, if you want to use RFC 6833 with a different data plane that allows you to use some of the features that might not be available with the Lisp encapsulation, this is how you would do. And that could be a draft, that we can bring up to this working group and discuss. Then, we'll decide what to do with it.
That's such an item might be reasonable. It's tricky, but it's also not in charter right now.
Well, the charter, let's have a discussion on that.
Yeah, control plane. Control plane work is fine, but talking about other data planes.
Let's have a discussion on that. I mean, right? So let's specify how the control plane can be used with, for example, layer 2. And what is interesting here?
That doesn't affect the IOAM work. That's not control plane.
No. What I'm saying is that IOIM is an example of what cool things you can do in an overlay,
yes,
right? When you
I'm
have
trying
Lisp
to
control plane and
determine
you have
the
this capability.
To the Lisp working group. I like the IOAM work. I
No.
understand it. That's not the question. The question is, what does Lisp have to do with IOAM? We gave you the time because I'm happy to, but I don't quite understand what the envisioned usage is.
This is Dino. Joel, so what if they said that the data that they gather from this data plane, even though it's not chartered in the Lisp working group, is data they may want to store in the mapping system? That could be in charter. But I don't know if they're saying that.
So my
I
point.
need to think about that.
Yeah, Joel, my point is that I think we are a few steps away. So I think the question on Guji adoption for this particular draft, I don't think is on the table today. I think the working group should think, and I can bring up a draft where I try to specify how you can use 6833 with another overlay. And, and that I think is a discussion that we should have in the working group. Then, the working group will decide what to do with it.
Frank Bruckner's one additional piece of context, which is a little orthogonal, but we have running code for this very encapsulation in VPP FIDO. There is running code of this very encapsulation in hardware with a bunch of chipset vendors. We're using Lisp implemented in Open Daylight in the mapping system to go and control the VXLAN encapsulation. So very much the solution that Fabio was referring to. So we are already using the fact that control and data plan have been decoupled. And this overall thing is integrated in OPNFV, fast data stacks, to build a full stack solution where you basically set up tenant networks, which are VXLAN based and Lisp controlled through OpenStack. So the thing is happening as we speak, and we can say, okay, we don't want to have it here, but it's there in the industry and it's happening. So go back to the talk that Dave Ward did the other day, where he said, well, let's make sure that we reflect what happens in the industry and don't close our eyes and put our head in the sand. So maybe I think the linkage that Dino provided is a good way to go and find a vehicle to go and get Lisp to work on that.
Just a comment on this. You mentioned two things about the implementation. One is the VLAX GP this solution implemented, and then you mentioned that you are using the Lisp control plane to manage this. Now, the second part, the working group could be interested, because we are chartered on the control plane to support multiple encapsulation. Now, the encapsulation itself We are not chartered for. But I congratulations, you have an implementation, maybe more than one. I mean, that's good. That's good news. But it's just right now we are not chartered for this on the data plane.
Hi, this is Uma from Huawei. I see this as a different way, like, regardless of VXLAN data plane or Lisp native data plane, this gives Lisp actually OEM capabilities, which is good.
This is Dino. I have a technical question. Does the data only get written to the packet by the encapsulator and only read by the decapsulator? Is that how you intended it to work?
We haven't really specified that in the document as it is right now, but given that you have a concept of a re-encapsulating tunnel router, that seems to be a natural fit for something that would insert information
And it
in
would
there.
go, the original ITR would put this on,
Yeah.
RTRs would preserve it and might process it. That would be a new functionality for the RTR, but might process it. And then the ETR, in theory, if it supported this, would process it and strip it.
Yeah,
and
that's I was kind of thinking.
So all
that.
three of those, ITR, RTR, ETR, would be adding their node data fields into this format, and then when you end up reporting, you're getting information from
Right.
every one of those.
So the reason I brought that up is because you may have an RTR topology that's made up of a multicast distribution system, and I'm wondering if you thought about this working on multicast branches. That would be incapped, decapped along these branches.
It's certainly possible to do that.
So if the RTR can rewrite it, the information that was put on by the ITR, and they just add to the packet, boy, we're
Yes.
not going to have any data left for the poor user. But anyways, as it goes down this tree, the spec allows additional appends to happen to the packet.
Yes,
with the-
absolutely.
Okay, that's all I wanted to know.
So if you're replicating the packet, the information that was there before will be the same in all the replicas. The new information that you're adding may be different.
Padma, Huawei. Even though I really like the OEM, I am worried about one thing, is that how we're going to actually reconcile that with having to get it encrypted. And I hear what you said. Who is reading the information? How about eavesdroppers who actually get the packet in the middle? I know there's been so much of discussion both in SFC and other places about monitoring and the abuse of monitoring. Have you thought about that?
Sorry, that was a little quiet, so I didn't get all of that.
This is Dino. Well, funny you bring that up, Padma, because if this has to work with Lisp crypto, then maybe the data plane did just come in charter, right? So the big question is an ITR prepends this, puts this packet data in the packet, encrypts the packet, sends it to the RTR or ETR. Let's say an RTR because it's more interesting there.
Mhm.
It decaps, then decrypts, then can read the data. Hopefully the data is only in memory, so it's not exposed on the wire. So, I mean, the question for the chairs is this, if they want this to work with Lisp crypto working, then you're asking this IOEM stuff to go in the Lisp encapsulation format, or how it works with the data planes that have been defined in this working group.
So before you respond, I want to say something else. It's also about where the data is stored. What I'm worried is when you said this is stored in the map server, maybe that's not the way to go, depending on what we want to do. So I think we need to think carefully about what to do with this information, where it should be, who can read it. I think there's a lot of things to do there before we actually make a decision.
There's no reason the data that's stored in the mapping system has to be in plain text. It could be encrypted at rest as well.
I agree. Just to say some of our latest woes is the fact that this encryption is considered not enough by some people. And that's why I'm kind of erring on the side of caution before we actually say we will do this or we will do that. I think we have to look at the implications of what kind of comments is going to come from other areas.
Okay, thanks, but we need to move on.
Okay, so this is a draft Rodriguez-Natal Lisp PubSub version 1. List of authors. The last three are the result of a review and a conversation that's been going on in the working group. There were other proposals that were kind of adding a PubSub. We worked together, and this is basically a version that summarized the work done by
In
Matt.
that regard, we may want, as we move forward, to switch this to a front page editor or two editors and the other folks listed inside as
Okay.
contributing authors, because publishing it with 7 or whatever the number is
Yeah.
there, authors would be problematic.
Okay, noted. And, you know, basically Matt Bucader, Christian Jacquenet, and Stefano Secchi are the new authors. Next. So, publish subscribe, right? So this is basically a publish subscribe extension for the Lisp protocol. It's focusing on map server configured in proxy reply mode, right? So when the map server is sending the map reply directly to the ITR rather than sending it to the ETR. The reason is that the exigence for PubSub comes from SDN-like applications where the mapping is not changed anymore at the ITRs or the ETRs, but is changed more in the mapping database via an outbound API. So that's when you need to update the XTRs about the new state of the mapping system. So the messaging used is not introducing a new message, but is rather piggybacking on the map request. There is a notification bit that is basically asking for subscription during a map request. And if the map server supports the publish subscribe, or if it has resources for publish subscribe, we'll return a map notify rather than a map reply to notify that the subscription has been accepted. If for whatever reason the subscription is not supported or is rejected, it will be returned a regular map reply. So in this way, even XTRs that are not aware of PubSub, they can, you know, keep using regular map replies and map requests with the map server capable, PubSub capable. The publication of the actual updates of the mappings is done via map notify, and there is a map notify ACK that is basically confirming to the map server that the mapping update has been received. Next. Next. So this is how the subscription works, right? So this is the initial state. If you look up in the mapping system, in the mapping server, you see that you know, there are mappings for two prefixes in dark gray, 111/24 and 222/24, and the corresponding RLOCs in light gray. There is a the XTR that is basically going and look up for one of these prefixes. Next slide. So this is actually the map cache miss. So the packet is destined to 222. So the XTR will send the map request for that particular EID. Next. And the map request is a PubSub map request, right? So it's a subscribe message. If you note the color code, the map request will contain an XTR ID that is the identifier, unique identifier of the XTR, and that will be useful to identify the subscribers at the mapping system. And then that map request will have the notify bit set to 1, specifying that this is actually a subscribe request. The parts that are in black are, you know, basic RFC 6830, so there are no changes needed. The part in blue are already incorporated in RFC 6833B, so this is aligned with what is happening in 6833B. So the map request get to the map server. Next slide. And so at this point, the map server can add XTR1 to the list of the subscriber, and there is sort of a subscriber table that keeps track of the RLOC of the ITR that has done the subscription. So this table is the one that will basically point to all the RLOCs that are subscribed to a particular mapping according to this table up here. Next. So the map server is capable, is PubSub capable, so we'll reply with a map notify rather than with a map reply. And the map notify will contain the mapping with the EID prefix requested and the corresponding lock, and also a nonce to identify, that this is typical map request, map reply protocol. Next. So at this point, the XTR has been notified of the mapping and can encapsulate the packet and send the packet. Next. So let's see what happens when there is an update to the mapping and we have a publication, and let's see how the XTR is notified. Next. So the initial state is the one that we just saw. Next. There is a change of state. So now, for some reason, probably because of the controller has been changing the mapping for this particular prefix, the XTR that are subscribed to this mapping should be notified, right? And so the map server can look up at the table of subscribers and basically find out the R logs of the XTRs that needs to be notified. Next. The map notify is sent. So it's sent to the R log of the ITRs that are subscribed. And basically, the XTR can update the local cache that now is synchronized for 222 to the location 8888. Next. And as we described, right, the XTR will send the map notify acknowledge, acknowledging that he has received the notification of the change mapping. So we have an effective way to basically push mapping updates to XTRs that have subscribed to a certain mapping. And then we saw in the ICAO use case, this is something that is useful for that sort of application.
Clarifying question, Eric Nonberg. So the nonce in the map notified is not the same as the nonce in the map request.
The nonce is used to map the map notify ACK on the map notify sent by the MSMR. So it's basically a way to map back that you are receiving a map notify acknowledge.
But the XTR never gets back the nonce that it was in the map request.
There are no relationship between the two nonce, right? Yeah.
Well, my implementation does that. So the nonce that's in the map request should be returned in the map notify, and therefore the map notify ACK will also have the same nonce. I don't know if we were clear enough in the spec about that, but my implementation certainly does what.
You're right. We have a demo afterwards that Dino implemented, and you will see exactly that's the component. I'm not sure. We need to go back. It's a good comment. Let's check on the draft. Next. Unsubscription. So how does a subscriber unsubscribe for a mapping? Just sending a map request with the n-bit set, but the TTL with no ITR lock. So that is basically telling that the subscriber is not interested anymore to the mapping. And what happens if a prefix is unregistered from the map server? So a particular mapping is removed to the map server. In this case, the subscriber will get a map notify with TTL equals 0. So that's the message that is basically telling the subscriber that that mapping is no longer active, and there will be a map notify ACK as an acknowledge back. Next slide. Okay, so this is the demo that Dino put together. Next slide on Lispers.
May I ask a quick question?
Sure.
So in the request messages and the control plane messages, there is a lot of spare space, I mean, reserved space. Why this choice not to have an explicit bit to say, I want to unsubscribe?
Why don't we have an explicit bit for unsubscribe rather than using the TTL and this sort of thing?
Yeah, we have a lot of bits. And
probably trying to be efficient in terms of implementation, right? There isn't, I think, a super strong reason.
Okay.
But yeah.
Can you think about it?
This is Dino. If you process a map reply today with a 0 TTL, it basically allows you to delete the map cache entry right away. So when you get this map notify, it's the same code that you use. So
it's just, yeah.
If you have a bit, you don't even need to process the reply. I mean, with TTL, you don't need to look at the TTL 0. You have a bit that says, you're done.
You're going to look at it anyways because you have to parse all the EID records in there because this map notify may have other entries in it.
Okay, so there's been quite a lot of conversation, I can assure you, about that between authors, more than you want to know. And so this is the demo that Dino put together on Lispers. So there is a leak client that is actually sending a subscription map request. So the example we show that the map server creates a subscription state, and the map server does the right thing by storing the nonce, as it was discussed. And then we will see that there is a change in the airlock set. The change is driven by a map registration because that's the way, in this case, the mapping is changed. And then the map server will send a map notify to the leak client to publish basically the updated mapping. Okay, so here is the example. The first example on the top is basically showing a regular map request, right? The map request is going out from the league client for EID 333, and the map reply is coming back here with this particular airlock. So this is a regular map request just provided as an example. What happened when the client, the XTR, the ITR here, want to subscribe to this particular prefix? The map request is sent, but in this case, the N bit is set. So this is basically a subscribe. And the reply, rather than being a map reply, it's a map notify that contains the same information in terms of mapping, but is also notifying the XTR that the subscription has been done. Next slide. So this is the state up in the map server. So you can see that there is the EID prefix, the TTL, the associated RLOC of the subscriber, and then this is the XTR ID. This is basically the subscriber table that we were showing before, the way it's displayed in the Lispers implementation, and this is the nonce of the map request. Lispers.net is also taking track of the map notifies that have been sent in this column here. So what will happen next is that there will be a change in the database mapping, right? And Dino wanted to spice up the demo, so rather than using regular RLOCs, he's using RLOCs names. That it's much cooler. And so what will happen to the mapping is that for this particular prefix, 333/24, one new airlock record name is added, and the new name, the new airlock for this mapping is Joel and Luigi. Next. And here, okay, it's a little bit hard, but you basically see that in the first message, what is the first message? I can't read here. You can't as well. Okay, which message is that, Dino? It's the map request. It's a regular map request sending up the. Oh, okay. You are showing the registration updates. Yeah. So the part that we are showing, that is showing up here, is that we need to update the mapping, right? So this is done through a traditional map register. So this is just adding the mapping, the RLOC, Joel and Luigi, to the mapping of 333. This is just basically nothing new here. And then you see the result of the map notify, right? So at this point, the map request is sent, and sorry, at this point, the mapping has changed in the mapping system, and so a map notify needs to be sent to the XTR to notify of the change mapping, right? And this is the mapping, the map notify that is basically providing the new location, Joel and Luigi, to the XTR that is subscribed. And of course, there is a map notify ACK that is going back to the map server, acknowledging that there is a map notify. And if you look at the state in the map server, now the number of map notify sent is up to 1 because one map notify has been notified. Next slide. And this is the result on the leak client, right? The leak client is receiving a map notify, and basically you see that now there are two locators named for this particular EAD prefix, and Joel and Luigi has been added to XTR3. And I think that's the last slide, right? Okay. And that's it. So you also got a very cool example
Question.
how this works.
Eric Nordmark, a question. So what's the lifetime of the subscriber table? Is the soft state, or does it stay around forever, or what? That wasn't clear to me.
Sorry. That's regulated by the TTL, right? Yeah, there is a TTL that is basically associated as a regular mapping that keeps the...
Oh, so the subscriber, no, but it's the TTL of the mapping or a TTL of the subscription?
is a TTL, it's the same, right? It's set at the same value. Yeah, exactly.
Okay. So if I have a mapping with a 24-hour lifetime, the subscriptions would implicitly get a 24-hour lifetime.
Right. And if you want to update the TTL, you will do another
So-
map request subscribe, map subscribe, and you will get a map notify.
But that seems to imply that the map server now has to keep this in persistent storage, right, for 24 hours. So that if it restarts, it will still honor the subscriptions. So that part of reliability is important.
So the case you're describing is when the map server is
Restarting,
removed.
yeah.
Yeah, well, it's the state, yeah.
So all the machinery that's in 6830 about retransmitting refresh-based map requests would refresh the subscription in the map server.
But there's, I guess there's two different things, at least in my mind, the sort of lifetime of that mapping as opposed to the lifetime of the subscription. I don't know if they're necessarily the same, but.
I mean, he's making a good point because there's an XTR that's registering a prefix and that has a TTL. And why does that TTL have the same relationship of a subscriber? Subscriber may want to have notifications for less than that time, or maybe more than that time, you know, so.
That makes sense, yeah. Yeah. Okay.
Okay, thanks.
Jan Van Bloomberg LP. This actually, I mean, this may be a lot, but this actually ultimately is the enhancement to Lisp TE. And interestingly enough, what I've heard from IOM could actually nicely play with, with what we're trying to do. Anyway, so actually the bulk of the work, I've proposed the use case, but the bulk of the work has actually been done by Dino in this effort. And yeah, I'm ultimately, in many ways, presenting on Dino's behalf. Next. So, I mean, we did stumble on the idea. What actually got us thinking about it is, we were looking, like everyone else, to build pure routed fabrics. We were looking at commodity hardware. We were trying to use relatively simple middleware. The other big thing that was driving our efforts is we wanted to get out of purely using simple IGP protocols in our data centers. We were, thinking of capitalizing on some of those ISIS drafts. We actually wanted to build relatively decentralized control system, even though it may be very much in conflict with what Lisp does, but we were thinking of adopting Lisp for that. We wanted to operate in any physical topology, and we wanted those topologies to be reconfigurable, but ultimately, the biggest thing that we wanted to do is we wanted to have the ability that no matter what type of fabric we actually have at our disposal, is we wanted to have an ability to do a complete end-to-end OAM on any of the path available to us at that fabric and report on it. So next. So again, ultimately it's just a use case. We are, it's not a new problem. It's been debated for years. There are numerous alternative solutions to it. They're quite, again, there's certainly various people who have come to IETF and solved this problem. In fact, actually, when we looked at what folks that did the fibbing project did, we actually thought it was of great interest to us. We just couldn't find something that would work the same way for ISIS. But the biggest thing that we didn't like about all the different like route control solutions is that it created a relationship in which we had to create an EID, and that EID would have to correspond to a particular path. So if we maintain a rather dense fabric, and we have hundreds, maybe thousands of different paths through that fabric, we would have to be creating so many EIDs. So that's why we wanted to go and explore Lisp as an option. Next. All right, so why did we want to do Lisp TE? We've realized that, we could actually, that in the end, we could completely adapt it to other microservice architectures. We thought that Lisp TE could easily be adapted to VXLAN GPE, which I've just heard today. So that's actually very nicely playing with what we're trying to do. We're trying to, to us, locators are easily something that could be distributed in IGP, and EID is something that we could use Lisp for. Again, Lisp is not a routing protocol. We're thinking of using as such. We can do both. We can effectively use every device as an RTR, or we don't have to. We could turn it into something intra-domain. And we could use its pub sub system. Anyway, next. So after some conversations with Dino, we thought that we could enhance Lisp's ability to do RLOC probing. To do the probing of the general ELP path. What generates that ELP path could be any other application. That is not a function of Lisp. That is a function of IGP. That is a function of some intent-based system, whatever that may be. So ELPs would come from topology-aware systems. ELPs would be an input to the mapping system. So we're able to, what we're actually doing, so what we would effectively do is we would get the ITR to do complete ELP probing end to end. This could actually be combined with we could effectively take everything that has been done by IOAM and use all of that functionality to report on the paths that could be reported to the mapping system, that could be reported to other applications. We would use periodic probes to maintain path integrity. Again, ELP probing could still be optional because we could still use other systems that would probe the path. Again, same what was described in IOAM. We could collect TTL, we could collect timestamps, RTT, but we could just outsource all that to other systems. We could, again, they can be periodic. Ultimately, but the biggest thing that we were trying to figure out is that we would have numerous paths reported between any set of EIDs. Some of those paths, we would obviously have to have mechanisms to prune those paths. For that, we would use various graph algorithms. But in the end of the day, if we had multiple paths to different EIDs, we wanted to make sure that the switch over to any other path would occur in the middle in any of the RTRs. So the idea was try to create, as part of the Lisp header, was to create a path ID and use that path ID to effectively steer the packets in the RTR infrastructure. obviously, multiple paths between two EIDs could then traverse the same RTR. Next. So this is a very simplified view of this type of topology. As part of the discussion, we were thinking, can we use the nonce, or can we use the LSB? And it seemed like that both of that if we're going to use a 24-bit nonce, it's easily portable across different data plane protocols, easily convertible into, let's say, VXLAN, VNI, and I think for most, and I think ultimately, with considering all the silicon vendors that we've talked to, ultimately for our use case, VXLAN GPE would end up being in the end the data plane protocol, even though using all the capabilities of Lisp data plane. So I guess next. So again, our initial idea was pure path monitoring. What we've realized is that we could completely operate an independent link state IGP. We could even operate it independently of BGP fabric if we wanted to convert an experiment. Again, EIDs can be selectively registered with the mapping system. That is, we could selectively traffic engineer in our fabrics in the same way people traditionally have selectively traffic engineered with protocols like RSVP-T. We were thinking that the mapping system could be a controller base, or it could actually be integrated into the fabric. Again, we were thinking of using the link state database and graph algorithms to build ELPs. We can support both one-to-one and end-to-end relationships. Then probably we should look at some other OEM protocol, and ultimately the way we steer the traffic through those paths, whether we're probing or actually traffic engineering, is through the use of Lisp header in either the nonce or LSB. And the draft further goes into that description. Next. So we're certainly kind of like, look, again, it's a project that we're thinking of exploring. We kind of started some of the work, but ultimately what we want is, we could certainly operate both, data center BGP topology and Lisp TE topology, and selectively move certain workloads in the DC under Lisp TE. We can do some interesting manipulations to influence forwarding behavior. We're certainly interested in exploring the ability to use this on unnumbered interfaces and being able to use IPv6 link local addressing as we actually under Lisp TE. So that's more exploration work on that. Again, IGP for our logs and Lisp for service nodes, again, processes, pods, containers, unikernels, whatever ways to split things into microservices. We also were very interested in seeing if this work could be brought to the folks that worked on seamless BFD, because so far majority of the work on that assumes that once fabric topology supports some kind of source routing capability, be it label stacking, be it the use of V6 extension headers. But so far this has been a rather big challenge in terms of getting various silicon vendors to support it. Even those vendors that do suddenly realize that there are limitations of how big of certain tables can be. So we're certainly trying to see if this could be adapted to build multicast trees and reliably maintain them. And and potentially, I understand that this discussed at this working group, that maybe start adopting Lisp as a more of a generic control plane that can control any other form of data plane that comes along. So that was it.
Any question or comment?
So, Rashad Rahman from Cisco. I have a question on the, I'm not sure I understood what you're mentioning for SBFD. Are you just saying you're going to be using SBFD, or you need to extend the SBFD as it's defined today?
We don't necessarily want to extend, seamless BFD, but a seamless BFD has the capability to probe individual path. We were thinking of capitalizing of using Lisp as a way for seamless BFD. For the seamless BFD to be encapsulated in a Lisp packet and use Lisp-T as a capability to probe paths.
Okay. I thought you were trying to maybe exchange the discriminators
We
using Lisp.
We certainly, there is certainly some possibly, room. The discriminators could still be, let's say, exchanged using various IGPs, and
Okay.
there are drafts and approaches that describe that. But there may be an opportunity, and we haven't exactly thought it through, that maybe discriminators could be registered with the mapping system. But that, I don't think we've thought this through enough to really speak on that.
Okay, thank you very much.
While they're coming up, anybody who hasn't signed the blue sheets, we have the blue sheets up here. We're going to recirculate them because there may have been some people who arrived late. Thank you.
Hi. Oops. Hi, my name is Oriol. I'm a student of Polytechnic University of Catalonia, and I'm going to show us how we implemented iOS on Android and on iOS. WOR on iOS. So first of all, what is WOR? WOR is an open source implementation to create programmable overlay networks. It's written in C, and it's available for Linux, Android, and OpenWRT. It will be available for iOS and macOS soon, we hope. So it also supports Lisp, VXLAN, and it's integrated with OpenDaylight. So what about iOS? iOS, a lot of people think, including myself, that iOS it's Unix-based. It's Unix-based, but in reality it's not Unix-based. It's based on Darwin, that it's XNU. XNU means it's not Unix, and XNU is a mixture of Mac and BSD. And also iOS is not POSIX certified. This means that if you write some code that it's Unix compatible or POSIX standard, you are going to need to rewrite some lines of code to make it work on iOS. Also, the main languages to deploy applications for iOS are Objective-C and Swift. So what differences we have found compared to the WOR Linux implementation? Here you can see some examples. So Teamers have a different implementation. We miss Netlink protocol library suite. This library, we use this library in Linux implementation to be able to detect the network changes on the interfaces. Some signals are different or don't exist. In the iOS version, we need to replace some system signals for user-defined signals. We are unable to create interfaces and route sockets, and we're providing access to interface file descriptors. This means that we cannot send raw packets. Even that, we can say that the 80% of the WOR core code is reusable in that case. So, network extension framework. This this is the tool that Apple provides us to create VPN-based applications. So we use it to create the tunnel provider. We call it tunnel provider, the tool which creates the link between Swift and the WLOR code. So it allows us to manage VPN connections on system. It allows us to create tune interface, to route traffic to the tune interface, and jet and send traffic to the tune interface, and create and manage UDP connections, also TCP connections, but it's not the case. Also, it allows us to protect the WLOR sockets from loops into the system, because we are routing all the traffic to the tune, so we need some mechanism to avoid to enter in a loop. It was available since iOS 8. Before, it was necessary to talk with Apple and sign a non-disclosure agreement to develop an application with VPN or low-level network requirements. That's the case of OpenVPN application, for example. And until iOS 10, we need to request an entitlement with Apple. Now we need to request this entitlement for some functions. That's not the case of VPN. Now it's without entitlement. And within that entitlement was necessary to check some things when they pass the test of Apple Store. So that here we can see the architecture of the application. Okay, so when the user launches the application of the WLOR and it touches the button of connect, the WLOR application runs the tunnel provider. The tunnel provider is running in the background always, and when the tunnel provider starts, it creates the tune and starts the WLOR core process. The WLOR core process opens some sockets, and then after that, tunnel provider starts routing all this application traffic and system traffic to the tunnel interface. Tunnel provider gets the traffic from the tunnel interface and sends it to the core, to the WLOR, to the WLOR process, and the WLOR process sends it to the internet. For the incoming traffic, the procedure is the same but reversed. Okay, so now we are going to the demo. To show the demo, we have this MacBook that has Wireshark installed, and we have an iPhone that is running the WLOR application. The iPhone is connected through USB to the MacBook, and we are mirroring the screen and the network interfaces. The network interfaces mirroring, it's like when you do a port mirroring in a Cisco switch. It's the same. So we are connected through cellular and Wi-Fi interfaces to the Lisp beta network. Here you can see the AAD of the iPhone and the RTR and the map server model resolver that we are using of the Lisp beta network. So let's go with the demo. So allow me to organize the desktop because the resolution changed. Yeah, it's okay. So now we are going to start. No, first of all, tell us that when we are mirroring the screen on QuickTime, Apple activates the demo mode. This means that all the information on the status bar, only the status bar, it's demo, so it's not real. As you can see, we cannot see the carrier. So to avoid this or to solve this issue, here in this terminal, we are going to start pinging to the Wi-Fi error log of my iPhone. Okay, now it's pinging, so we are going to make a handover from Wi-Fi to cellular, and we are going to see how Wi-Fi error log stop responding. So let's start capturing packets in the Wireshark. So we have that filter applied, so we are going to see just the traffic that we want. So now let's see our current public IP address. Okay, as you can see, we have an IP of the IETF range. So now we are going to open the WLOR application. The first time that the user opens the our application, the application requests to the user to add a VPN profile to the system. This only happens the first time. Okay, so we recently reinstalled the application. That's the first time that I'm going to open the application. Okay. So here the request. So we need to allow it. Okay. So after the user adds the profile, the user needs to configure the settings. We preloaded the settings through the code to accelerate the demo. Okay. Save the settings, and then the user can push the connect button. So as you can see here, we can see the info request and the map register. So let's check again our public IP address. It's refreshing. Maybe that's demo effect. Let me restart Safari. Okay, first we are going to do a ping, okay, to show how we are encapsulating the packets. So let me ping Google. So we are now pinging, and Wireshark, we can see here the packets. And we are here. You can see how we are encapsulating the packets with our Wi-Fi IP address, and we are going. But the source address is our EAD. Okay. So let's try again. What's my IP address? Maybe another server. Let me check. Oops. Okay, this is working. So here we can see how we have our EAD. Okay, so now let's make a handover from Wi-Fi to cellular. So we're going to see the ping, so see how it's not failing or how it reconnects fastly. So let's disconnect with Wi-Fi. Just wait. Okay, and now we can see how here we can the Wi-Fi airlock stopped responding. We have another info request and map register, and now we can see how the packets are encapsulated, and what the source airlock interface is a cellular interface. We can see that the IP changed. So let's back to what's my IP and refresh it. Let me update it. Okay. So as you can see, here we have our AD. So thank you for your attention. If you have any questions, I want to try to answer it.
Shri Gundavelli, Cisco. I just have one question. What is the trigger for your handover?
Can you repeat the question?
What is the trigger for your handover?
The what?
Trigger.
The trigger. Yes, we are using a framework of Apple. We are discussing it with Apple engineers because I don't know if it's the most effective way, because Apple use a system configuration framework that we can register a notification system that the system, when detects some changes on the networking, that doesn't mean that detects, for example, it's something like more higher level. So it sends a trigger to the system that tells, okay, you are reachable, your Wi-Fi interface is working or it's not working, your cellular interface is working or it's not working, but it's fully controlled for Apple framework. So because we don't have access to the interfaces. So
does the framework allow you to specify, if the RSSI value falls below certain value, I want to hand over from Wi-Fi to LTE. Does it allow you that level of control?
It allows you to detect the change. After detect the change, we can do what we want. So I don't. Or can you repeat the question? I understand you. Or?
No, I'll catch up. I'll sync up with you later.
Okay.
Yeah, thank you.
Thank you.
Hi, this is Dino. I have 4 quick questions, and I think you answered the first one. It's running on iOS 11 now, right? Because I saw the control panel. Okay.
Yes, it's running on iOS 11.
Okay. And the the next question is, you're sending info requests and info replies. That means it can support going through NATs as well?
Can you
I mean,
repeat?
I know in this demo that's here at the IETF is we're not going through a NAT, but does the implementation work going through NATs?
With or not?
NAT devices,
Yes, it works with or not also.
Ah, okay, great.
In fact, I think that now it's going working without NAT because our Wi-Fi network of IETF gives a public IP address, so it works on both ways.
And you were talking about switching over from one to the other. Can it use both interfaces at the same time, LTE and Wi-Fi, so it's multi-homed and load splitting packets?
Like load balancing, or
like what?
Can you repeat the question?
Can you keep both interfaces, the LTE and the Wi-Fi interface, up at the same time and make it multi-homed and make it active-active? Does the framework allow you to do that?
Yes, you can. Always iOS always tells to WLOR core procedure that the interfaces are up. So I think that you can, but I'm not sure if you can use it at the same time, both interfaces, because I think that you always are working on a sandbox or something similar. So the final bind or the final decision of what interface used to send some packet, I think that it's this decision. It's part from it's decided for the iOS kernel. So I don't know if we are going to be able to decide what interface to use.
So on sending, I mean, if we don't get send and receive on both, if we could receive on either, in other words, if the remote ITR can RLOC probe and find the better path and come in on either direction, that would be more useful than if the framework only allows you to send on one. That's not the end of the world if you could receive on both.
Yeah.
That would be cool.
Yeah.
Okay, and my last question is do you think it'll work over the Bluetooth interface as well?
Can you repeat? Sorry.
Do you think you can add a third
with
interface
Bluetooth,
and make it the Bluetooth
if it's going
interface?
to work it. I think that yes, because
That would be cool, because
yes.
then you can do peer-to-peer networking, just like this.
I think that yes, because the Bluetooth interface, I saw when I was developing the application that the Bluetooth interface is treated like a network interface. So you have some flags and I think that you can use it. But I need to try it. So
okay, great. I think it's great work. Well done. Very well done.
Thank you.
Okay, thank you.
That's all?
So while you're disconnecting, I'm going to ask one last question. Will it run on my watch?
Maybe.
Okay, we have to try that.
Unless somebody comes and throws us out, we will let Dino give his full presentations.
Okay, we're going to present Lisp digital signatures. It's a draft that we sent out in July, the IETF in July, but we didn't have time on the agenda in July. So it's had the original version and then one revision to it. And what the draft covers is authentication and authorization of ITRs using the mapping system. Describes details on how to sign map registers and how to sign map requests and how to store public keys in the mapping system. This is how it works. XTRs are assigned public-private key pairs, one or more, depending if you want to have multiple EIDs. We introduced a concept called a crypto EID, and a crypto EID is an IPv6 address that's divided into two parts, a prefix and the hash of that XTR's private public key. And it can be used as a source EID or simply a signature EID. So the system doesn't have to use this particular EID to source packets. It can be used just to sign, because it needs to, when it signs, it has to describe it has to identify the public key that it's signing with. So the signature EID is that hash that is provided in packets. So what we do is we store these hash to public key mappings in the mapping system. They're registered by third party, or it can be registered by the XTR by itself, doesn't matter. It could actually be in the same instance ID of the EID to RLOC mapping, or a different one. And what the XTRs will do is they'll sign these map registers by using their private key. The map server then receives the map register and gets the hash from the signature EID and looks up the public key in the mapping system, uses the public key to verify the signature. Both the shared key and the signature verification is required to accept the map register. So the reason this is interesting is if I look at Joel and we want Joel to register the mapping system, we want Joel to identify himself that he's Joel. But just because he's Joel doesn't mean he's allowed to join this particular instance ID. So the shared key that's associated with the instance ID and EID that he's registering also has to match. So there's kind of two layers of authentication going on here. XTRs also sign map requests with the nonce and the instance ID and EID. So maybe I'm not registered the same instance ID as Joel, but I want to look him up because I want to talk to him. Well, I have to sign my map request, and I may not be allowed to get mappings for him. So this not only authenticates me, but also authorizes me if I'm allowed to get the mappings for him. And if you do a map request and you get a map reply back, obviously the signature succeeded and you're authorized to get the mapping. Otherwise, you get a negative map reply back saying authentication failure. And no more data than that. So some of the benefits of this scheme is that we have strong elliptic curve cryptography because we're using EC-DCSA versus all the traditional Diffie-Hellman RSA. We can verify and invalidate a single XTR, which is good. Previously, if you registered a bunch of EIDs to an instance ID and one of them had to be invalidated, you'd have to change the key and everybody would have to be updated with the new key. So now you could invalidate a single entity. We can use the signature ID for registering other EID types. So maybe I have some geocoordinates, maybe I have an IPv4 address, a MAC address. These are things I want to register, but I use this IPv6 crypto EID as a signature EID only to register those things. So it's just not limited to registering IPv6 EIDs. And now that we have access to the public key of these XTRs, we could actually encrypt the results going back. If we have the public key, the map server could actually send, maybe with PubSub, could actually send map notifies and encrypt the map notifies with the public key, so only the XTR can decrypt with their private key. So this provides some identity privacy as well, because multiple key pairs can be used. So you can actually combine this scheme with the ephemeral EIDs that we have in another draft. Ephemeral EIDs is just picking a random number and constantly changing them as you connect new TCP connections. But here, now you can have multiple key pairs and you can authenticate for each one if you want. So let's show you how this works with some running code. So this is a little program that actually will allocate the key pairs and create the hash. So if you want to provision a new XTR, what you would do is you would give it the prefix. Here, the prefix is using my write-based Diana thing with S1FE that stands for CIF. So it's a /64 prefix that's being used. If you go a little bit further down, you'll see that the crypto hashed EID then is that prefix, and then the low order 64 bits is the hash of the public key. That public key that you see towards the bottom is what's registered with the map server, and then there's the private key that's stored either in software or hardware on the XTR. Oh, I pointed to it and I forgot. So that's the That's the prefix for the hash. That's the crypto EID. And that's the private and public key pair. So what you do in the third party that's going to register the hash to public key mapping, you would register this sort of prefix. The convention we decided to use in the spec was we'll use a distinguished name as an EID prefix and use the leading characters hash dash as an ASCII string, and then append the hash value with that as an instance ID. And then we decided that the RLOC, that we would store the signature in a JSON type LCAF. And you can see that a little bit further below. That RLOC is pointing to a JSON name called pubkey54b1, and right below it you can see there's the signature in a JSON string. Okay. Then if you look at the database mapping, that's the actual IPv6 EID that you want to register it. We tag it as a signature EID equals yes, and then we would register this particular mapping. The RLOC for this mapping is on that interface and angle brackets. Okay, here's the map register, comes to the map server. And if the public key is not registered to the mapping system, the verification will fail. And you see that right, you see it at the top of the circle, it says public key not found for this signature EID. And so the signature must fail because you don't have a public key to verify it. You do not accept the map register and you return a negative map reply back with authentication failure. Okay, this is a map register that has a good signature on it. In this case, the authentication passed for the share key, allowing him to register this particular EID with this particular instance ID. The lookup of the crypto hashed EID was successful. You see found, right? I can't point to it. Found, and then we do the verification and it worked, and then we accept the register, okay? On the bottom, we're showing how the signature is being good for a map request. Now I want to look up this guy, and the signature verification passed. Same thing, the hash to public key mappings looked up in the mapping database, returned to the map server or the map resolver. This could be a map resolver only system that would do a lookup of the hash to public key so it can verify the signature. Draft status, we're not requesting for a working group document this time. We want to get more implementation experience for this, but we think this is possibly a good feature. Some of the things we could do in the future with this is actually encrypt the exchange between the XTRs and the mapping system. We also may want to figure out ways of publishing hash to public key mappings for map servers, so encryption could go in the opposite direction from XTRs to map resolvers and map servers. Questions, comments?
Rashad Rahman, just question. I mean, I haven't read your draft, so I forget how much you're encrypting, but what kind of performance impact do you have? Because you're using public private key, right?
So this draft is solely just putting signatures in the packet. There's no encryption, because it's only solving authentication authorization. But now that we have a public key system available, we have the opportunity in the future to decide when and where to encrypt.
Yeah, very interesting. I think there is an easy elliptic curve equivalent to do a Diffie-Hellman exchange. Have you looked into that for the Lisp crypto extension in terms of efficiency?
What kind of? I didn't hear everything you said.
I think there is a elliptic curve equivalent to EC. Well, not equivalent, but there is a version of Diffie-Hellman exchange that uses a
DPM. I didn't.
Diffie-Hellman.
DPM.
Diffie-Hellman. DH.
Oh, Diffie-Hellman. Yeah. This is using a elliptic curve.
Okay.
It's using I forgot what curve we're using, but I don't think it's 25519, which seems the most popular one, but I forget what library the implementation is using.
No, what I was saying, if there is an equivalent for Lisp crypto where you can use elliptic curve for the Diffie-Hellman exchange and make it more efficient, the Lisp crypto encryption. Well, let's talk offline.
The Lisp cryptograph already uses elliptic curve.
You already support EC? Okay.
Oh, yeah.
Perfect.
I think you used ECDSA for public key private key generation. He's asking about DH. so that you can create the secure channel.
Yes, that's another RFC. That's the data plane, and we already support it. It's Cypher Suite 4 and
That
5
is-
uses ECDH
you do
with
it-
AES encryption and Cha-Cha 20.
I know, I know the data plane encryption part, that is XTRs to DH and get the security to do the data plane encryption. He's asking if the same thing can be applied
That's
here.
not what he's asking. He's asking about the data
I'm asking
plane.
what he's saying. I think it's right that there is a support for. Yeah. Thanks.
But the thing is, the discussion of DH and DCA is mixed up here.
I'm not understanding what you're saying, Uma, but we could take it offline.
So this is Albert. Let's say if I got you right. So when you want to authorize a map request, the map server will. So the map request will be signed.
Yes.
Okay. Then the map server will take the public key, will hash it, will verify that.
No. When the map request is signed, the signature EID is there. And when you have the signature ID, the hash is in the low order bits. That hash is used as a lookup key to the mapping system to retrieve the public key. And once you've done that, you
And
can
how
verify the signature.
how did the public key got there?
A third party registered that hash dash distinguished name.
Okay.
A map register is used to register it, but the question is, where does it come from? It can come from an SDN controller. It can come from the XTR itself. It could come from a provisioning system. Yeah.
You have to worry about who's authorized to enter those, but that's
Oh, but that's easy too,
operational.
because when they send a map register, they have to, the shared key has to be accepted from, so it has to have a security association between itself and.
One way to attack someone is to cause there to be a different public key for them, and then they can't register because their private key doesn't match the public key.
Right.
So you
right.
got to protect against that too, but
Yeah.
it's a
So
pretty natural part.
it's
of it.
always a good sanity check when somebody actually registers that the hash actually maps, that you perform the same hash algorithm to make sure that the hash and the public key actually map, right? And there's some other data that's in there too, so it's just not the public key. It's your EID concatenated with the instance ID as well.
It's just that's not spelled out in this draft for obvious reasons.
It is.
Oh, okay.
Yes.
Great.
Just a comment to this, Suma. So this is very good for Lisp. Actually, it's giving basic security properties. And what is important is also anonymous IDs, the ephemeral IDs generation. It's one-way hash. You cannot, maybe with this approach, you cannot do multiple ephemeral IDs can be generated. This, I'm not sure about that. I think Bob was working on this, but I can compare to this is basically hip, high, and hit. It's
So-
like public key, private key pairs, and
Yeah, I thought about this quite a bit. Is the ephemeral EIDs from the other spec as general or random as hashes? And I think the conventional wisdom is that hashes are pretty random in their own right as well. So, I mean, I think these crypto EIDs are pretty anonymous. And I think if you continue to change them at the expense of provisioning keys. Key management is not a trivial matter. So you have to consider that, you know, if I configure an XTR, should I give them 16 key pairs that they can just spin and use? And the answer is yes, they can do that for sending data packets, that is.
yeah, this is one of the discussions we were having with Bob. Like, you know, he has the same problem. Earlier, when you do ephemeral identifiers, it's easy for you. With this, you got into the same problem Bob has. We can discuss offline how to do this, actually.
Okay.
Yeah, we are already over time.
Oh,
So if you
go to the next
move-
one.
Yeah.
Okay.
Please. Sorry.
Okay, this should be shorter. This is a draft that Padma, Uma, and I put together. We got a lot of good expert help from Peter Ashwood from Huawei, so thank you for that. This should be pretty short, but it might be a controversial presentation. So what are we trying to do? At the highest level, we're trying to simplify the mobile network. This proposal is called Lisp Mobile Network, which is not the same as Lisp Mobile Node. Lisp Mobile Node assumes that the EID and RLOC are co-located in one device. This is running Lisp in the mobile carrier network to simplify things and enhance mobility. And so the goals of the new 5G network that's coming out in 2018, release 15, and release 16 coming out in 2020 is to be able to meet these new latency and bandwidth demands for VR, AR type applications. 1 millisecond latency and 1 gigabit worth of bandwidth. Very tough requirements to meet, but we're going to try to do that. And address more demanding applications like IoT. How can we scale billions of devices, orders of magnitude more than the number of cell phones that are in the world today. So we think that a pull-based mapping database will help scale and secure for the number of IoT devices that will be out there. And we think that using a pull-based system rather than distributing lots of state everywhere, we could reduce OpEx and we could allow incremental deployability. There's two ways we can do incremental deployability, is that since Lisp is an overlay, parts of the mobile network could be the overlay and other parts could still run the way it is. Or we can use Lisp inside a network slice and support it actually in a lot of places, but it would run side by side with other services. Of course, we want to do dynamic encapsulating overlays, which GTP, the current tunneling protocol inside the mobile network, isn't. It is a statically provisioned sort of network, but we maybe think we could use GTP or Lisp as a data plane, but we just make these dynamic encapsulating overlays, which means the outer header changes depending on where the host or the UE is right now. So this is going to create fast mobility handoffs and allow roaming. And the important problem that I believe needs to be solved is not only do we want to roam within the mobile network, we may want to roam across mobile networks, and we may want to roam from mobile networks to Wi-Fi networks that are not deployed by that same carrier. This is how it works. UEs are the devices, the cell phones. They're assigned EID addresses. They can be IPv4, IPv6, or both. Doesn't matter. The terminology I'm using in this presentation is LTE terminology. The 5G terminology applies the same way. We just put these functions in the UPF. UPF are both physical and virtual and can be put anywhere in the mobile network. But I like to describe eNode Bs and P gateways because they're specifically they're at a specific physical location in the mobile network. So those eNode Bs and P gateways are Lisp XTRs that could be running any type of data plane, and they're assigned RLOC addresses. Those RLOC addresses are already assigned to those devices in the network today. They come out of the space that's being allocated by the EPC, and they could be routable by the underlay, and they're aggregatable. The encapsulation occurs over the EPC. That's the Evolved Packet Core, the IP part of the network. And the encapsulation does not happen over the RAN. Everybody is sensitive on the number of bytes that go in a packet over the RAN to get this 1 millisecond latency. So we're not doing encapsulation over the RAN. The way packets are sent over the RAN today will continue for 4G and 5G applications. The encapsulation format could either be GTP or Lisp, but done with a real-time setup. The reason we want to keep considering GTP is because we want to be sensitive to the 3GPP needs about not changing too much in the network. Go ahead.
Quick question, Dino. So where does the encapsulation start?
I'll show you in the next slide.
Okay, thanks.
The underlay is the existing or next-gen EPC or NGC core IP network, and the overlay runs over the EPC. Okay, so here's a sample packet flow. We'll show packet flows for various source destinations, and then we'll show that the UE moves, and we'll show you how it's done. The way this slide is notated is that the white line is where the TCP connection is happening. So we want UE to UE traffic to happen here. All the nodes that are in green are nodes that are not modified at all. The protocol stack, the applications, and the network layer are not modified at all, and they're assigned EIDs. Where you see red boxes, those are where the Lisp XTR functionality is put, and they're assigned RLOC addresses, okay? So in this example, when the UE on the left-hand side wants to originate a packet, it sends it like it does today. It could be an IPv6 packet, IPv4 packet. It has no encapsulation. It gets sent over the RAN just like it does today. The eNode B receives the packet, does a lookup for the rightmost UE in the mapping system that is managed and deployed by the mobile carrier, and you see it's there in the EPC network. And then the left eNode B knows to encapsulate the packet. That's why you see the red arrow. It means encapsulated to the rightmost eNode B's RLOC address. It strips the outer header and then delivers it unencapsulated to the UE. Right now, packets have to hairpin packets that go from UDE to UE have to hairpin now through the P gateways. So we're going to eliminate all the packet traversal over the multiple hops from E node B to P gateway back to E node B. This is an example where the UE now wants to talk to a server in the internet, a server that is not in a Lisp site, so it doesn't have an RLOC, and it's not an EID, it's just a routable address. The packet from the UE to the E node B would move just like it did in the last slide. The E node B would look up that IP address of the server in the mapping database. It would not find it because it's not in a Lisp site, so there's no RLOC. So what it does is it defaults to one of many P gateways. Those P gateways can be clustered, so it can load split. All the E node Bs that are doing this could load split this across all the P gateways that are available. P gateway gets the encapsulated packet, strips the outer header, and delivers it natively to the server. This is a situation where the UE wants to talk to a server that's behind an XTR, which means it's in a Lisp site. That could be a server that's sitting in a data center where that XTR is a top-of-rack switch. This is quite interesting because this is the first time we can get the shortest path from the E node B all the way to where the packet has to go, and the P gateway is out of the loop. It's not part of the data path. This could be a feature or bug depending on who you are and where you sit in the standards organizations. But basically what happens is the packet goes from the UE to the E node B just like it did on the last two slides. The E node B does a lookup and finds that the XTR is all the way over there in the data center, encapsulates it directly there. That packet flows many, many hops via an RLOC address all the way to the XTR. It decapsulates and maybe sends it on a single link, because it's the top-of-rack switch, to the server. We're going to move now. Okay, so we have this UE, and we're talking to this server. We now have showed it has an EID of 2001::1. So the packets are being moved just like we showed a couple slides ago. Now what happens is the UE is going to move to the rightmost E node B. Okay, what happens is, well, it either originates a packet where the E node B recognizes that 2001::1 is a new EID that it's attached to it, or when the Security Association and provisioning parameters are set up in the 3G network or 4G, 5G network to tell the E node B that somebody is just attached. That's probably a good time to register the information, because you could minimize packet loss if you do it before the real IP packets start coming. So what happens is the E node B now registers itself as the RLOC for the 2001::1 EID to the mapping system. And then it tells the P gateways or any other E node Bs that have the old RLOC cached that they need to do a new lookup. We have three mechanisms in Lisp today that we can do RLOC set changes. We can use small TTLs, we can use SMRs, which is the same procedure that ILMP uses to update locators, or we can use pub/sub. These are the three mechanisms we can use. And they all have different levels of scalability and convergence properties. We could also use predictive RLOCs. There is actually a fourth one. If we know that this UE is moving back and forth in a metropolitan city area between these E node Bs, maybe the remote ITR can encapsulate to both of them, so there's no signaling when handoff happens. And so packets will go to both places, and it will find where the EID is at the expense of backbone bandwidth wastage or extra packets sent on the backbone. So this specification is describing how the Lisp architecture and protocols could be used in an LTE 5G mobile network to support session survivable EID mobility. We will have TCP and UDP sockets stay up during all these moves. We're going to find with millimeter wave that these cells are going to be smaller and that people will move across subnets more often. And the need to keep the same IP address is going to become increasingly important. So we need to have the mobility at the IP network layer. A recommendation is going to be provided to SDOs on how to integrate Lisp into the mobile network. Now the next slide is controversial. Might not be. So what do we want to do? This is not an IETF proposal. This is a proposal by a bunch of people that want to work with all four standards organizations. We're going to make all standards organizations be part of the solution so we don't have the non-invented here problem. Okay? we've already presented at ITU, at CNGP, and we're planning on going to 3GPP to present this. The only reason this is an internet draft is because we wanted to publish the information somewhere. So we're going to try to have the personalities and people that are involved in these other standards group help evolve this solution, but this is the beginning of it. Now note, there are no protocol changes that have to go into Lisp for this. It uses the same EID mobility mechanisms that the ICAO that we just heard for airlines is using, that VM Mobility is using. So comments, questions, I'm done with that.
I have two. So you have still versioning also as a mobility mechanism.
Oh,
also.
I'm very sorry, Luigi.
This is my comment is, your system, you are assuming that in your mobility scenario, you keep the same IP address.
The same EID, yes.
Yeah, which, I mean, I can imagine it's true if I stay in my operator networks, but is it guaranteed if I change, if I do roaming and go in another provider network?
I mean, if the EID address is provisioned either by the manufacturer statically, like MAC addresses and IMEIs are, and it's, Luigi Iannone, that EID has never changed for you. You were born with it, you use it all the time, right? So the question about address allocation will be simplified, but it will have to be addressed either by the manufacturer or by the cell provider on giving you static addresses. Now, are static addresses good things? Are they trackable? The answer is absolutely yes, but we have mechanisms for EID privacy.
Have you thought about using the ID you have in your SIM card, in your chip? You have an ID there.
Well, yeah, good point. So you could take the chip ID or the IMEI. There's all kinds of unique IDs. There's even a UUID on most of these phones that could be used as part of it as well. But that will be really static and tied to the physical device. And that means, if one day Luigi has this phone and I know it's Luigi, and then I find out Luigi's doing stuff in Virginia, it might be Joel that has the phone now, right?
I just want to add something is that this draft is also coupled with other work happening.
Speak up a little bit.
Yeah, I was saying this draft is also coupled with other documents which are looking at the aspect of provisioning and how to integrate it with the 5G, specifically for the mapping systems and so on. So this draft is just part of the whole solution. There is much more being published elsewhere.
Yeah, thanks for that, Padma.
So this is still an overlay solution, right? I'm wondering how the 3GPP QoS, how do you see this working with the 3GPP costs? Let's say if you enable, a cost but for a particular flow, right? How does that work, when you have a handover in this case?
The QoS, the QoS, are you talking about?
Yeah.
The 6830 specifies that you copy the inner header QoS to the outer, so it's maintained across the core.
But if
the TOS bits in an IPv4 and the flow label in the IPv6 is copied to the outer header when it can be.
Right.
Meaning a flow label of 24 bits can't go into an outer IPv4 header of 8 bits.
You can do the marking, but my point is the P gateway has to allocate the resources, right? Initially there was P gateway 1. It has allocated the network resources. So now after you hand over or you route the flows through a different path, you're no longer anchored through the same P gateway. So now I'm wondering how you move the cost states from P gateway 1 to P gateway 2. That part is,
well, I mean, like Padma said, there's a lot of other specifications and there's a lot of other machinery that's operating here. That makes 3GP and the whole mobile network working. What we're trying to show you here is a way to get shortest paths on the data plane and pulling state from the mapping database. There's a lot of other stuff that needs to be worked out, and that's why we want to go to all these standards groups that have expertise in this area.
No, absolutely. I think I understood the overlay approach. You can find the optimized route, but my point is, you need to have some interworking with the 3GPP signaling so that you can move the cost states. Yeah, I agree. Yeah.
One quick answer. The mapping system here, what is envisioned here has to be part of the 3GPP.
Can you speak into the mic, please?
Okay, mapping system here, Lisp mapping system is one of the components in the 3GPP. That is what Padma was describing. It is described in its CNGP document.
I just want to add something. There are other documents who actually show how the actual registration involves the mapping system in the 5G. These documents are currently under review, and so they're not ready yet, but there are much more machinery behind us. But the part that Dino is presenting today is just the data plane, and we know that the GDP control plane, there's a lot of discussions happening right now, and there's a lot of things in flux. But at least this shows one solution without anchors, which removes the triangular routing, and that's what we're really trying to push.
Yeah, thanks, Dino.
Thank you.
Probably the answer to that is yes, but I assume that you guys are working on all the different aspects of, like, service function chaining to integrate into the solution.
Well, I mean, as you know, Jan, RTRs can be placed anywhere in the EPC to hop through different things. And since we know there's going to be a lot of virtual functions that are going to be in the 5G network, we could hop through them where necessary. Now, you got to be a little bit careful about that, because we can suggest all this functionality, but as you take additional hops, it's going to affect this 1 millisecond latency thing. And if that's going to be in the data path, there's going to be a huge cost to the end user for special applications.
Or for many people who are just interested in, say, placing traffic shaping devices or any, I mean, then this is not infinite, and people will want all kinds of things to control that.
Right, agree. So one thing I forgot to mention, but I do want to mention, is that Peter and the guys up in Ottawa have done some really good research on this, on generally using ID locator separation on a 5G network. And they've done it with some real devices and virtualized some stuff. But maybe next IETF we can show you a demo of that. But if you're interested, and we could put on the agenda, but that would be really cool.
Demo as always welcome.
Okay, great, thank you. Go ahead, Rashad.
I'm curious, what kind of scaling numbers in the mapping system you would need for that kind of functionality?
For the mobile, okay, so what I'm trying to scale is IoT, which is order of magnitudes more than the mobile system. So I'm going to start there and then scale it down to mobile node. So I know that's a kind of a tongue-in-cheek and hand-waving answer, but there's bigger fish to fry in IoT. Now, having said that, in the IoT, we think the majority of devices aren't going to move as fast as mobile phones are going to move. It may not be true, but the class of devices are going to be stuck in light fixtures or wherever. So, or what? Or attached to mobile phone. Well, which would be the worst of both worlds, so to speak. Yeah, but we have to do the scale. I have some slides of how to deploy a mapping system with 1 billion nodes in it. And if you just do some back of the envelope calculations, if you only store 1 million entries in a single map server and cluster 1,000 of them, you're at 1 billion. I don't think the state is the scaling problem. I think it's distributing the map request load across the mapping system and trying to fix DOS attacks of the mapping system is the thing that should keep us up at night. And that's the stuff that needs more people to think and look at.
Peter Ashford-Smith, Huawei. Thanks for the plug.
Oh, no worries.
Just on the scale issue, we've been doing some experimentation with PubSub in conjunction with Lisp-like data plane, because we think that the mapping and the scale of the mapping is actually the larger part of the problem. The data plane sort of just works. And part of our experiments, we've been using Google PubSub. We've been using Microsoft Azure. We've been using different massive scale, already deployed, already working on the billion scale pub subsystems. And we're seeing 100 or 200 millisecond response times just using those existing systems. So that's the current state of the art. There's 20 or 30 odd years of massive distributed database work that's gone on in the world. And what Google and the others are doing is what we could actually achieve with a worldwide scale mapping system. So it's very promising, and I invite you to look at our demonstration if you're interested.
Yeah, it's an interesting comment, because will application level databases scale better than a DNS-like structure like DDT? And I think we need to do experiments in this area to see what is better. Now, all these database schemes all have the same sort of problems they have to do it. Have to deal with. So I'm not sure What I think some of the advantages of Lisp DDT is that the same database does not have to be stored everywhere with a lot of the DHT-based systems do. But the cost of that is that you have to go find the information when you need it. And do you want to pay the cost at that time? So, really interesting stuff. But a lot of people have said, why don't you connect a bunch of map servers together with Cassandra or the blockchain? I don't know why people think the blockchain could scale. It's a really long linked list, right? But I mean, the UPC guys are doing a lot of research and trying to figure this stuff out. And so keep doing it, so keep giving them money to do it too. Go ahead.
Just one clarification for his question. It also depends on where you are putting the mapping system. Scale question doesn't come into picture at all. If it is a 4G system, today the P gateway region is 1,000 kilometers. So in the 1,000 kilometers, whom cells and IoTs are connecting, if your mapping server sitting in the control plane, and if it comes to 5G, the 1,000 kilometers shrinking to 100 kilometers. That's why your UPF mobility comes into picture. That's why Lisp is solving that. That's the crucial problem 5G is contending with. That is the key solution here. And also one more clarification is for Louis' question. EIDs, we need to be a little bit careful here. If it is roaming between providers, EID have to be changed because there's a lot of machinery registration has to be involved. But Dino's solution here is between UPFs. That's the biggest use case in 5G that can be solved with this, because the provider is same there.
Okay, you're the last questioner. We're way over.
Oh, well, then I'm going to open a whole other Pandora's box. No, this is very good, but I was wondering if this goes forward, do you think that there will be additional security requirements that show up? I mean, I'm just trying to figure out, you said that right now, what you showed, there's no changes to the protocol, but do you think that there will be more requirements down the road?
I think it's probably going to be inevitable. I mean, maybe Padma or Uma could comment to that. I asked the question yesterday at 5 Gang IP if Lisp crypto would be required and how much, how much encryption versus monitoring of flows people need, because that pendulum has to go back and forth. So yeah, I'm not sure how much security has to be put in. It would be nice. It would be an added feature.
Actually, that's a very valid question. The mapping server, if it is put into the provider's control plane, it has to have an optional interfaces where it can attach to the authentication and all the stuff. So it has to be, mapping server interfaces has to be defined so that it can be plugged into their system.
Has everybody signed the blue sheets? If you haven't,
Yeah.
please come up.
I just want to add one thing, is that one of the things that we've been looking is not only the placement of where the mapping system is, how distributed it can be, and what is it. I think there's one question that we haven't really approached here is how do we leak those prefixes so that we do not have this massive problem of, and it's a little bit different from PubSub as well, because we will have to really integrate with the 5G roaming scenarios. And actually, this is under study right now, at least by our team. So anybody who wants to collaborate with us, that's more than welcome.
Absolutely.
Okay, thank you very much. See you in London.
Atma, can you take these?